Dear students, welcome to the advanced CAD for application class. And yeah, in this session, we will simulate a gear drive. So a gear drive consists of two revolute joints because this gear rotates about this axis, right? We have to select that revolute joint, or we have to make one revolute joint for gear one. And also another gear rotates about another shaft. We have to make another revolute joint for gear two. And select a gear joint, and in that gear joint we have to select two revolute joints, and also we have to select the ratio, speed ratio. Okay, so speed ratio is nothing but, so gears are used to change the speed of the shaft. Okay, increase the speed of the shaft, one shaft with respect to another shaft. Suppose this shaft is rotating 100 rpm, right? 100 rpm. So because this shaft is connected to small gear, so suppose yeah, this gear is 3 times bigger, so 3 times bigger than this gear. So then this shaft rotates about 300 rpm, 300 rpm. Okay. So you can choose the speed ratio by knowing the number of teeth. If you know the number of teeth, suppose N1, this is a gear 1 and this is gear 2. If you know the ratio of number of number of teeth, N1 by N2, that is the speed ratio. So in this case, this gear consists of 30 teeth and this gear consists of 10 teeth. Okay, speed ratio is 3, just 3. So that means this shaft rotates 3 times faster than this big gear shaft. Okay. Also, so that is one choice. If you know the teeth, number of teeth, you can count the number of teeth and N1 by N2. Or if you don't know the number of teeth, you can select the circles, pitch circles, ratio of the pitch circle diameter. Okay. So this pitch circle radius by this pitch circle radius gives the speed ratio. You can select while selecting the gear joint. You will know all these things when we select a gear joint, when we make a gear joint. Okay. So parts are specified, parts are already given and uploaded in your Google class. You can download from Google class. Okay, Google class stream section, or in Google Drive share link. I shared some link, right? In that link, I provide all the parts. Okay, so start digital mockup DMU kinematics. And here, yeah, we need to insert the parts, right? Already I made parts, so we have to specify existing component, insert the existing component in product one, right? Select product one and insert existing component. If you don't have parts, we have to make new part here. Okay, you can also make new part or make new part in part design and bring here. Okay, yeah, you have to use part design or generative shape design to make new part, existing component. I already have parts. Okay, those parts are gear 1 and gear 2 and part 1, sorry, fixed base, these 3 parts. Okay, so now gear 2 is hiding, gear 2 is hiding in the gear 1. So we can go to assembly design and we can move that gear, bring this. Okay, or if you don't want to move, then no problem, you can just specify this axis and gear 2 axis same, then automatically gear 2 comes here. Okay, when we select a revolute joint. Okay, so but if there are many parts, okay, if there are many parts, use assembly design first. Okay, use assembly design first and arrange according to drawing, according to assembly. Okay, and later, So use assembly design first, arrange according to the assembly, okay? Assembly means, so if the gear 1 is here and gear 2 should be here, okay? So arrange using some coincidence constraint or some contact constraint or offset constraint, all these things, you know, right? How to use assembly design, okay? And later, open the simulation, kinematic simulation workbench, okay? That is easy for you. So here, I'm not using the assembly design. So without using the assembly design also, you can move these parts, okay? So here, click on the compass, snap automatically to select object, okay? Right click here. I want to move gear 2, right? Gear 2 is hiding inside gear 1. So move this direction. So the direction is y-axis, right? Y-axis, select this line. So right click, snap automatically to select object. Okay, gear 2, select gear 2, and that is y-axis is here. Okay, that's y-axis. Okay, so drag the y-axis line. Okay, you can do like that, or use assembly design and move. Okay, or if you don't want to move, no problem. When we give a revolute joint, automatically move. Okay, so that is the first step, and second step is, so fix the part or select a revolute joint. Okay, so select a new mechanism. Okay, you have to create a new mechanism because no mechanism is existed. Okay, because we are making the joint, first joint, right? So that is gear drive mechanism. So gear drive mechanism. Okay, and line 1 is, you can either select the shaft 1 line or gear 1 line. Okay, I'm selecting the shaft 1 line. Yeah, this one is gear 1 line. Okay, and shaft line. So here, if you don't see the shaft line, okay, shaft line, you can hide the gear 1 if you cannot select line 2. Okay, so line 2 is nothing but shaft axis, right? So hide the gear 1. So then you can easily select the line 2. And again show that one, again show, right click, again show. And a plane 1 is this one and plane 2 is this one. Okay, null offset, you can click null offset. Okay, no problem, click on OK. So null offset means this shaft moves to here, okay, or this gear moves to up to this shaft surface. Okay, that is okay. So that is a revolute joint 1, and again make another revolute joint. So don't create new mechanism again in that gear drive only. Okay, so some students are clicking on new mechanism. So we already have mechanism, right? So only one mechanism we have. So if you want to create another joint in another mechanism, create new mechanism. But I want to create this revolute 2 joint in the same mechanism. Okay, same mechanism, no new mechanism. Okay, so line 1 and gear 1 is this one, and plane 1 is shaft plane, and gear 2 plane is, yeah, gear 2. So you can also select YZ plane, right? This is the front view, YZ plane of gear 1 and YZ plane of shaft 1. Similarly here, YZ plane of gear 2 and YZ plane of shaft 2. So no problem. So here hiding, right? Now planes are hiding. You can show the planes and use null offset. Okay. So you can check the angle driven later after creating the gear joint. Okay. And here not moved, right? If you want to move that one, update. I already selected this line, and this line must be same, and this plane and this plane must be same. This plane and this plane must be same, and this line and this line must be same, but not moved. Just created a constraint. Okay. created constraint. So you see, these are not updated, not updated. So you can update here or use Control U, okay? Control U. So go to product and update the mechanism, update the mechanism, okay? So yeah, if you know which parts to assemble, then you can directly create joints without assembly design or without moving the parts and all these things. And here you can bring that back. Okay, so now we have to create a gear joint. I already created revolute joints, right? So revolute joints, degrees of freedom now 2, because 2 gear joint, 2 revolute joints, right? 2 revolute joints. And also fix one part before making, you can fix that one later also. Yeah, revolute 1 and revolute 2. So now a gear joint, make a gear joint which consists of 2 revolute joints, okay? So same mechanism, don't create new mechanism, same mechanism. So revolute joint is already created, or you can create there itself. Revolute joint and revolute joint to, you create, and here this ratio, gear ratio, right? Gear ratio is speed ratio. So now 3, because this gear consists of 30 teeth and this gear consists of 10 teeth, 30 by 10. Yeah, because here revolute 1 is gear 1, right? Gear 1. So that's why 3. If you select revolute 1 is this one. If you're selecting revolute 1 is this one, then 1 by 3 is the gear ratio, okay? So you should be careful. So I am selecting revolute 1 is the first one, right? So that one divided by this one is 3. If you're selecting revolute 2 is the first one, and you have to select 1 by 3 here. So suppose if you don't know this ratio, if you don't know this ratio, then if you know the pitch circle radius, okay, so define here, define. So radius 1 is this one, and radius 2 is this one, okay. So it's automatically calculates the radius ratio 3, okay. So click on OK. And also not same direction, opposite direction, right? Suppose this gear moves, rotate in this direction, this gear moves in this direction. Rotational direction is different, right? Okay, click on OK. And here either you have to check this one or this one. You can do that later, okay? Not now. So after fixing the part, you can do, or if you want, you can do now, okay? So you have to specify the range, right? So specify the range when later you can specify that range, okay? So I'm not checking now, I'm not checking, click on OK. Yes, now DYS changes to 1, right? DF changes to 1. So because only one gear joint, and again here, fix the part, right? Which one fix is the best? This is the base part. And still DYF is 1. Why? Because I did not specify the angle driven constraint and specify the range of the angle 0 to 360 degrees. Okay, 0 to 360 degrees. And if once you are finished, right, you can hide all these things. Okay, hide, and you can hide all these things also. Select this one, select this one. So I just want to see the gears. Okay, yeah, fixed and everything is okay. So fixed part is there and joints is there, and we have to specify the angle driven constraint, okay? Angle driven here. So opposite and -3 in here, angle dribbling for revolute one, either this one or this one. Okay. So suppose this gear is rotating this direction, counterclockwise direction. So this gear should rotate in the opposite direction. Okay. So I am specifying from 0 to 360. Okay. 0 to 360. So counterclockwise direction, anti-clockwise direction. Okay. This direction. You can check here. Okay. Which direction it is moving. So click on OK. Okay. Or you can also check this one. Okay, -360 to 0. If you want to make this gear rotate in the other direction, -360 to 0, that one. Or this one is 0 to 360. Okay. Okay. 0 to 360. Click on OK. So only first limit. And now you will get a message. This mechanism can be simulated. Okay. If you're not getting this mechanism, this one, after setting this one, checking this one and all these things, after making all the joints, I think you forgot to fix the part. Okay, fix this. So then you can select a simulation. So which one? Gear drive is a mechanism, right? These are the material. Steel, iron, all these things are material. Gear drive is the mechanism. Okay. Yeah, before inserting new simulation for edition, edit the simulation, you can edit. You have to check that one before, okay, whether it is working or not. Drag this side, and after that, insert, okay, and change the loop mode. I want continuous simulation, rewind. After finishing rewind, continuous simulation, and change the time step. And here, I want to click this one, forward button. If you want to make forward simulations, this button must be here, and this button must be here. So here, click jump to start, then these two buttons are here. Okay, this one is reverse simulation you can do. Now you cannot make simulation if you click, because both the buttons are at the end. Okay? So both the buttons are at the start, supposed to be at the start. Okay, yes, click on OK. Yes. So you see this gear is rotating slowly, but this gear is rotating fast, okay, because number of teeth are less. So click on OK. If you want to further slow down the speed, okay, yes, select this simulation and simulation player and rewind option, set the parameters, so 0.001. Yeah, click on OK. So then play button. Play forward button. Okay. Slow. Okay. So that is the gear drive.